Okay, so let's get into this practice exam for 2023. This is the updated version from 2020 to the new system, the Nucleo board. So let's get started with question 1 on interrupts. So other than program-specific logic, what should happen in an interrupt handler and why should it happen there? So the main thing that we're going to do in an interrupt is, whenever we get interrupted, we'll do something that we want to do with a program. So this is like a button gets pressed and something happens based on that. A character jumps, we record data, we show a new screen, something like that. Uh, but then we also have to uh, unset the interrupt flag or clear interrupt flag. So unset/clear the interrupt flag. And the reason for that is because we've got this flag that says there's an interrupt that happened on, say, EXTI, an external interrupt. And if we don't clear that flag, it'll think that we're not done handling it. So this is our way of telling the system, like, okay, we've got it. We've handled that interrupt. You can move on to doing other things. Otherwise, in some cases, like with a hard fault, for example, when there's a memory error in the system, we may not be able to continue running the program until that error is fixed. And in some cases, it might be really difficult to fix, it might require multiple attempts, things like that. So we have to explicitly unset the interrupt flag or clear the interrupt flag for the system to continue. And why does it happen there? We need to indicate to the system that we're done handling the interrupt. Okay, so now we're on to part B, which is assume that the Ethernet message starts when the line changes from 0, low to high. So we're looking for a rising edge, right? Good to note for later. You can assume that the received bits directly from PE3. So that's our GPIO pin number that we may need to reference again later on. Show any bits that should be set in sys CFG EXTI CRX, EXTI IMR1, EXTI RTSR1, FTSR1 to trigger an interrupt on EXTI3 when the message starts. Leave any unchanged bits blank. So for this, we're going to need to dive into the manual, and I'm going to start this by going to roughly page 78, which is where our sort of system memory map is. And it looks like the first thing we're looking for here is syscfg EXTI CR blank. So let's go ahead and find syscfg in this table. It should be somewhere around here, page 80, I think. And there's syscfg, so we're going to jump to there. And now we can look at what registers are doing what in here. And it looks like we're looking for something in syscfg EXTI CR blank, and it tells us to fill in the blank with the correct number. So we're looking for something relating to PE3. And we should know from using the external interrupts before on the Nucleo board that the EXTI numbers are linked to the GPIO numbers. So if we see EXTI3, that's going to mean the same thing as PE3. And we can see that listed here, that it says EXTI3, and that's linked to syscfg EXTI CR1. So we know that it's going to be there, and we know that it's going to be bits 15, 14, 13, and 12. So we know we're going to do something here, and the rest of the bits are going to be unchanged or blank. So now we need to know what value we're going to set for syscfg EXTI CR1. And so we can either, do a control F and find it here, or we can just scroll up to where we find that table in the manual. And here we see the description for syscfg EXTI CR1. We've got an address offset if we need it, which is 0x08. And then we could find the base address where we found this original link on page 80. And then we want to look at bits 15 through 12 and see what it says that we're doing there. So it says we've got EXTI3, and this configuration is written by software to select the source input for the EXTI3 external interrupt. And we can see that one of these is listed as PE3, and it's listed a little bit different, right? So we do have to know that PE bracket 3 is equivalent to PE underscore 3. It's unfortunate the manual uses a bunch of different terms for the same pins, but in this case we should just know that that's the same thing. So we're going to fill in the values 0100, which is binary for 4, and if we just kind of count up from PE PB, PC, BD, PE. That's 0, 1, 2, 3, 4. And so that's the value we're showing there. Next, we need to look at EXTI. And so again, I'm going to go sort of back to page 80, which is where we initially found syscfg, and EXTI is not far away. It's right up here. So we'll click on that, and we'll look at what EXT-IMR1 and EXT-RTSR and FTSR look like. So I'm going to scroll up until we find the actual description of this. And we know that EXT-IMR1 is the interrupt mask. And it says interrupt request from line X is masked, or interrupt request from line X is not masked. And hopefully we know from doing a few examples with the external interrupts that what we're doing here is we're setting the same bit number as the EXTI number or the GPIO number. So since it's PE3, we're going to be setting bit 3 to a 1 here. And that means that we won't ignore this interrupt coming from EXTI3. Let's scroll down and see that RTSR is rising trigger selection register and FTSR is falling trigger selection register. So when it says circle 1, we want to circle RTSR because we saw in the details we're going from 0 to 1, and that is a rising edge. So that's what we're looking for here. And then RTSR and FTSR are structured the same way as IMR is, such that a 1 in that position is enabled, rising triggers enabled for that input line. So we're going to put a 1 again in bit 3, and that's all we've got to do to set up the external interrupt and be able to detect it on this Ethernet message. So that's it for problem 1 on the practice exam.